It's live now. Okay, so we're gonna continue. Studying the methods that we study on Tuesday. We began on Tuesday, and then I'm gonna create a class here, and then the class I'm gonna name it static methods and field. We're gonna see the static methods and fields today. Okay, we saw static superficially on Tuesday. Now we're gonna see this a little more in depth. Okay, so I'm going to create our main method, right? And right now, I'm going to, as a member field, I'm gonna just write public static int my number. Okay, and now I can simply just print my number. Okay, as simple as that. That's how you declare a static variable, right? And the good thing of this is that you can call that variable because you are, calling the variable from a static context. That's why you can call a static variable. If I put this here, I'm gonna get an issue here. It says that non-static field number cannot be referenced from a static context. So in order for you to call a variable outside this method, the variable has to be static because you call static variables from a static context, right? Now, if I do this, public void print is an example, right? I can say this out my number. I don't have any issues. Why? Why I don't have any issues here? Can you tell me why I don't have any issues here?
It's not static.
Correct. So the variable is not static anymore, so I can call it from a non-static context. But I cannot call it from here because this is a static content. So for me to do that, I have to make this variable static, and then I can call it from here, and I can call it from here too. Because from a non-static method, you can call a static variable. So if I just run it, I get 10. Because I'm not, okay, of course, I have to call the method, right? But now we have another issue. And what is the issue? Can you tell me what the issue is now? Why am I getting this red line here? It's the same principle. Why am I getting this red line here? Guys, because I'm calling a non-static method from a static context. You cannot call non-static fields or methods from a static context. Okay? So we have to make this method static. Right? Now, I can find the solution here by calling this method just one moment. This kind of froze here. Just one moment, please. So I will have to force this guy to close and open it again. It's now responding. I'm going to open it again. Okay. Static method field. Okay. So now what I can do is, okay. So what I can do is create another method and make it public, right? Void print. Just an example, Sys out my number, and then call print from here. Yeah, but we're gonna have the same issue here. What I can do is just create another public int my number 2, and then give it a 20 value. And then I can just print this guy from here from a non-static method. Okay, now if I run this guy, right, I get 10 and 20. What's going on here? Yeah. Yeah. What I can do is copy this guy, go to here. Yeah. It has to be static. So we have to make this static. And then it works now. Okay. So don't forget that you have to call from a static context, you have to call a static variable. And now we get 1020. Okay. As simple as that. Okay. So these two variables are static, right? And then we can only call those static variables from a static context. Okay. That's why we have this guy here. Okay. So that's this little program about static. Okay. Don't forget that this, and guys, let me ask you a question. What is the default value What is the default value of this variable? Class number 1. I think it was class number 1 of this course. What's the default value of that?
I'm debating between 0 and no.
Well, you have to make your mind. In the exam, it's only one answer.
0?
You see it. 0.
0, right?
So the default value of static variables, integers, is 0. How about this one? How about this one?
No. No one is a no.
Nice. How about this one?
Double is going to be 0.0.
Makes sense? And so is float. Okay, 0.0. Okay, how about this one?
It's going to be null as well, object, right? The same as string.
Makes sense? Because object is a class, right? And so is string, right? Good. So those are static verbs. Okay, so let's create another class and let us call it why am I getting these spread lines here?
When you were trying to run the command, to run it, you press something under the run command in the menu. I think it made all that.
Okay. So IntelliSense was done is weird. Okay, IntelliJ. Okay, so let me have a class called launcher. Okay, launcher. And in launcher, we're gonna have PSVM. We're gonna have this guy. And then I'm going to try to get this main method here from here. Okay, I'm gonna try to grab that from here. Okay, so I'm gonna say, you say that this method is static, right? What did we say about static methods to call them from another class? What did we say last class? Do we have to instantiate the class? When we have static methods, we don't create an object. We can simply just mention the class and then the method and then pass the args. Remember that we have here a value. Okay, we have a parameter here, an argument. So we have to pass the argument, right? Now, if I have to run this guy, especially this guy, I'm gonna get exactly the same. Because all of these guys here inside this method are the arguments. Okay, this is what it accepting. So if I put the arguments here, I just try to pass those arguments. That's what I get. All these guys here. That's why I am printing this, and then I'm getting the same thing. Okay, I get the same thing. And if I want to access this particular variable, is static. So what I have to do is just sys out the name of the class and then the variable. And then you print the variable. So we get here number 10. I can do the same with the other ones. I can say number 1, and I think it's number 2. No, number 1 doesn't exist. Let me see. It's number 2 and number 3. So I can say here number 2 and number 3. Okay, and then we get the same thing. Okay, so to access a method from another class, when the method is static, okay, if we try to access a static method, we don't have to instantiate the class. In other words, we don't have to create an object of the class. We simply type the class name dot whatever we're trying to access, either a variable that is static or a method that is static, like here. Okay, I have another method here, Do I have enough?
Why would you want to do one versus the other? What's the
Is what you're trying to avoid instantiation of this. For example, let me think of an example when you would do this.
to me, it seems like if you have to instantiate it, it will take more memory time to go through the process of instantiate. I mean, depending on what you're
Yeah, when you
doing,
create an object, you have
it
to
will take,
separate space and memory for that. But
yeah.
for this, you don't have to do that. You're simply calling the variable. You're not creating an object.
But on the other hand,
Yeah, go ahead.
then any method within the same package will be able to access it, right? Actually, is it the world?
This has nothing to do with access. The one that has to do with access
No.
public is the one. This is the access modifier. This is the guy. This is just makes it static. So you can call it from static context. And also something that we're gonna see when we get there, static fields or methods are loaded before the other ones. They're loaded before.
Interesting.
We're gonna see how they load before anything else. Because you can have static variables like this, static, and then do this, right? And then here you can create variables like a public int name, well, string name, okay. And then the SB. It always gives me this error because it seems that it's a misspelling here. But if I say something like Mary, it will not do anything. Okay. Now I can call this variable from here, right? And say this out. Name. Then I'm resolving this. Oh. Okay. So now, if I just comment this out, so my number is 10 here, and my number is 30. Right? If I print this, you see that 30 goes first. And print, it never prints it. It's just, you know, it reads this before, then this. It's just, it have this 10, and then here it resets it to my number. Okay. You may have this reset here, right? This will give you an error, just in case you want to reset this before you get to the main method. This is a static section like member variables, right? So you put all the status guy here. Now, if you want to reset this number before it gets here, you will have to create a static block and then reset that, like give it another value. Okay. Okay. And then it will print 40 instead of 10 because the value is reset. All right. So my number here is going to be 40. Let me uncomment this out. So when you have several stuff like, you know, different things like that, and when we get to the order of printing, you're going to see that static elements print first, then normal elements, and then constructors. So we're going to see the order when the class prints, statics print first, then anything else. It's the first element that prints when the class loads. Okay? So whenever you create an object, you're basically creating space in memory for that object. The advantages of creating a static method or static variable is that you don't have to create an object. You simply, by the class name, you can call those variables or methods. So you don't have to create space in memory. You simply do that. Okay. Some people don't like static variables because they are kind of exposed outside this supposedly safe environment. Okay. And, you know, they don't like this. Okay. But it has its advantages. Okay. It has advantages. Now let me create another class named another main. Okay. Another main. Okay. So this one is going to say, sysal, well, let me create our friend main, sysout, and I will say print in another main. Okay, that's all for this class. Okay, now we're gonna go back to the static guy, the launcher, and then the launcher, we're going to say another main dot main args, like we did with the first one. Okay, now we print this guy, the launcher. We're gonna get all the things that we intended to before, plus print in another main. So, guys, what we have to do is simply call that function, that class, right? and whatever belongs to that class. I don't even have to import the class. The class is not even imported here. Okay, you don't see the class is not even imported, right? If I create a method, let's say I create a method here, say maybe main equals new main. It's not main. It's another main. Another main equals new another main. It gives me here, it says instantiation of utility class this. Okay. So this is unnecessary. I don't need to use this. You see? As you can see, I don't see any of the things that are static. I don't see anything. Okay? If I create something static here, did I see the print method? The main. Let me see if I create another method here. And I say public, static, string, print name, right? Let's just pass a name here. And let's say return name. Okay, so that is a method that is static and returns a name. So from the launcher, I want to call the method. You see, I don't see what is the name of the method. Print name. Print name. Let's see. You see, it's not here. Whereas if I say this, another man, and I say print name, it's right here, simply because it's static. So let me pass Carlos, right? Because I have to pass a name. So this is not needed because the fields are static. Okay. Now, if I run this guy, I get what am I running the launcher? Oh, I know why. I know why. Because remember what I told you the other day? If I return something, I have to catch it. I cannot just call this. This will be ignored. What I have to do is either store it in a string, right? And then print the string, right? That way it works. So now I see Carlos here, right? Before I couldn't see anything because I have to store it. Or I have another choice. I can just print the method call directly. Print name and then Carlos. That works too. Okay. If I print this, I have Carlos 2 times. So that's possible too. But this will not do anything. Okay. This will not do anything because I'm just returning something, but it's ignored. Okay. You see, only 2 times. This doesn't do anything. The only way that I can do anything is by storing it in a variable and printing the variable, or just simply print the method call directly. Okay, that is possible. Are you guys understanding?
Yes.
Yes, yes, no, 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 yes.
Yes.
Okay, so in another main, we can declare a variable. We can say public static string SSN. And then we can say 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Right? SSN. Now I can come here to the launcher and just print this out. Another main SSN. There you go. We have access to that variable because we declare static, and then we use the class name and get that variable from there. Okay. Let me create another one. Say protected static int, or let me say char gray. Right? I can come here and say this out, another main, gray. Because remember, protected, you can see it from the same package, right? From a subclass in the same package, right? And from the world. Well, not from the world, from those two guys. Okay. From the same class, protected is from the same class, right? From the same package, and from a subclass or a child class in the same package. Okay, that is protected. How about default? How about default? How about default? Can we see default? If I just print default, we can see it. Because default is from the same package and from the same class. Okay, that's why we can see default. And then we get B here. How about private? Can we see private?
No.
Let's see it. If I just try to print this, and I say another main, I don't see private anywhere.
No.
Okay.
Only within the same class.
Yeah, only the same class. So the only way that I can print this guy is from the same class. For example, if I just say this out, private string. Okay.
Or if you pass it to another variable that is got is public or static, I can't remember.
You're talking about the getter, right?
Uh-huh.
The getter. Okay. Yes, the getter. So this private guy here, we can create a getter, right? And you can use the, the guy that creates the getter, but I prefer to do it by memory because in the exam, you have to remember that, okay? So the getter, it just returns, this is a string, right? String, so it returns a string. And then I can say get private string, right? And it will return the private string, okay? So with the getter, which is public, right? I can simply access that variable that is private, right? By simply, of this guy, we can say another, and then we say, boom, we don't have anything. Do you know why?
Don't you have to pass it to?
Do you know why we don't get anything? Do you guys know? Well, the answer is simple. This method is not static.
Oh,
That's why you cannot see anything here. So if you make it static, right, then you can come here and do this dot here, and you say get private string. So now, if I just run this guy, I'm gonna get private string. It's right here, private. Okay. If you want to access elements with the class name, you will have to make those elements static. Otherwise, you cannot see them. Okay. If I remove static, right, and I create an object of that class, and I say another main equals new another main. Now, if I do this, print, I am, and then we see print name, and we don't see get. We don't see get anywhere. Okay. The problem is, well, I have made this static, and I can remove this guy, and then yeah, I start getting a lot of things here. I better not do it because I'm gonna start to fix everything. So I'm gonna put it the way it was before, okay? And here the way it was before. Okay. Okay, so now I just fixed everything. Everything is fine. If we run this guy again, everything is fine. I could have fixed that, but I don't have time for that. Okay. So beautiful. So we're accessing all the static fields and methods from the other class by simply typing the class name, and then with the object notation dot, we get the variables and we get the methods are static. Just like you see here, guys. Static, static, static. Okay. Yeah, I'm reading here. In Java, static keyword is mainly used for memory management. It can be used with variables, methods, blocks, and nested classes. It is a keyword which is used to share the same variable or method of a given class. Basically, static is used for a constant variable or a method that is same for every instance of a class. Okay? So you don't have to instantiate anything. So an instance variable is a variable that you create, and you can create an object and get them. Okay, but this is static variables and methods. You don't have to instantiate anything. Okay, and instance variables can only be accessed from static. Static variables or fields can only be accessed from static contexts, like you see here. Okay, so if I try to access, and I think I did this already, but I do it again. Just a regular method, like say result, okay, and then I try to print grade, right? But it's protected, right? So now if I just run this guy, another main, You see? We have to call that method from somewhere. This is not printing anything because that method has to be called somewhere, okay? But I cannot call it here because a method that is not static cannot be called from a static method, right? So I can create another method that is not static and call this one, but what other method is gonna call that one? So this is gonna be an endless thing. I can say public void print result, right? But this is gonna be like a rabbit hole. There's no end for this. I can call result, right? Not a problem. I can call this method, but who's gonna call this one? Then I have to create another one that, print results, print results, right? And then right? And I can call that method print results, right? Okay, that's fine. Who's gonna call this one? Okay, so it's kind of difficult to call a static method, a non-static method from another static method, another non-static method, but who's gonna call the method? Okay, so from this static guy, I can say, let me call result. You see, but it gives you a warning. It tells me non-static method result cannot be referenced from a static context. So you can only call static methods from a static context. Okay, so I'm gonna delete all these guys. I don't need them. Okay. So I can call the getter from here if I want to. Get, and that's fine because I'm calling this guy that is static from static context. So I can say this out, right? And I can just get this guy, right? And I can just just run it, and I get this beautiful word private, because it's returning this variable here that is private, and I'm calling it from here. Okay. And like I said, this is going to consume more memory than storing that in a variable. Like for example here, private text, right? Private text, and calling the method from here, right? And then printing private text. That's going to save you memory, and it's going to be faster because you call the method only once and then store that result in this variable, and then you just use the variable from that moment on. Okay, and that's going to give you the same result private here. Okay, so that's another way to test that. Okay. Okay. So let me create another class. Let me call it counter. Okay, call the class counter. Right. Let's do some practice here. Counter. Now, I'm gonna say public static int count. Okay, and I'm gonna say public int, no static this time, int another count. Right. I'm gonna create a constructor. Constructor is just a method that's the one that constructs the object. Okay, it doesn't return anything, it's just creates the object. But you can put because the constructor is going to be called when you invoke that class. Okay, so public counter, and the constructor has the same name as the class. Okay. It has the same name of the class. Now, once we do this, okay, and then another count, we just increment it by 1. Now, guys, when you instantiate the class, as soon as you instantiate it, the first element that's going to be called from the class is the constructor. This is an explicit constructor. I created, but if there's none, Java will create one for you. It will just provide one for you. In this case, I'm creating one. Constructor is just a method, right? That is called as soon as the class loads after the static blocks. Okay. This is the guy that is used to create objects. Okay. Okay. Remember when we do this, counter equals counter. I'm sorry, counter, and then new counter. Okay, this is a constructor. So this guy is this guy. Okay, so whenever you instantiate that, you have counter, you're going to have these variables right there because they are in the constructor of the class. Okay, and we're going to see them now. So let me continue. Okay. Now, let me create the main method. Okay, PSVN. Right? Now, I'm going to create an object from that class. I'm going to call it counter one new counter, creating an object. Right? We just create an object of this class, counter. Right? Of this class. Okay. Now we're going to do the same. By instead of 1, it's going to be 2. So we're going to create 4 objects. 2, right? 3, and 4. So we are invoking that constructor 4 times. Okay? So now I'm going to print count, right? Count. So with this here, what we're trying to is to test how the constructors are called. And every time that you call the constructor, you know, when you call the constructor, you say count or one.count, what's going to happen? It's going to increment that count. Okay? But let's see. Guys, what is the value of count here? Can someone tell me?
0.
0. So what's going to happen when you call this constructor? What's going to happen to 0?
Going to go +1.
Makes sense.
But it's after.
Makes sense. Okay, let's try to do that. So right now, if I call this guy, right? It's 4. Why 4? Let's continue. You see. This out 1.count. Okay. Oh dear. This is a warning.
Because you instantiated 4 times and then you increment 4 times.
Yeah. That's what I'm trying to. Let me see now. Yeah, when you instantiate 4 times, 4. Okay. So all of the objects are updated. because they belong to the same class. So I'm gonna say 2. And then we have 4, right? And then we have 3. And all of them have the same value because all of them belong to the same class, right? Now I'm gonna do this now. Right? And then I'm gonna do the same thing again. Okay? Let me print it now. You see how all of them are updated? Because they belong to the same class and all of the objects are updated. Okay? Now if I do this, oh. Look at that. They're back to 4. Okay? What if I do this? Back to 5. Okay? Remember, increment and later use, right? Right. So, as you can see, all of the objects are updated at the same time. Okay? So you call that guy 4 times. 4 times when you just discount is 4 times. When you call this guy, it's going to be the same value 4 times. Okay? Now let me do something else. Let me do something else here. Let me get same guy, but now instead of count, let me do another count. Okay. Let me do another count. Right. It's gonna be 2, 3, 4. And then if I run that, I get 1, 1, 1, 1, 1, 1. Okay? 1, 1, 1, 1. Because this guy here, if you print the value of this guy, right, from here,
You won't be able.
I can't.
Mm-hmm.
I can't. Because remember, it's not a static one. Okay?
So how come you can print it at, hold on. How come you can print it here?
Yeah. One moment. Okay, let's debug this. Okay. So I'm gonna, okay. So this guy, the value is 1. But the value before was, let's just put the breakpoint somewhere else, not here. I'm gonna put the breakpoint probably here. All right. And then let me debug that. Okay, a moment. So run it, debug counter. Okay, so counter It's just here. Let's me just move. Another counter is 0. You see? Now I come here. Remember that another counter is not static. Okay? So I come here and then move to this guy, and another counter is 0, and counter is 1. Okay? So now I come again, and another counter becomes 1. Right? So now I just call this guy. That's the object that I created. It comes back here. It calls, every time that you create an object, you're gonna call this guy, okay? The constructor, okay? And then it comes back and then adds this, and then another counter becomes 1 again, and count is 2, okay? Then it comes again and create the second object, and then it's gonna call that particular constructor. Then counter is going to become 3. See here? And then another count, still 1. Right? Now we're going to come back to the other one and create object number 3. Right? And then call the constructor again. It's going to increment count. Right? Count becomes 4. Right? And then another count is going to be there, 1. Then it comes down here, create the object 4. It just prints count, and count is 4, right? And then prints 1 count. 1 count is 4 too. Remember, this count belongs to the class counter, so it's the same value, right? You create an object 1 that accesses the count, but the count is 4. So it's going to get 4 too. 4, and then 4, and then 4 again, and then 4, right? Then it comes here and increments 4. Now the count is 5. Then it goes down and prints 5, 5, 5. So all of this is 5. Now it's going to decrement. Now the value of count is 4. It's back to 4. Then it's going to go 4, 4, 4, 4, 4, right? And then we'll increment to 5. So the value of count is 5 now. It's going to go 5, 5, 5, 5. Now, another count is 1. Okay? It got here 1, 1, 1, and 1. Okay. The original value of this guy was 0. Okay. Remember that always static is run first. Okay, that's why it's calling this static count so many times, and this one is not. Okay, and this one remains 1 all the time. It's gonna run the count, the static. That's why whenever you create an object,
But it does call it once and increments it.
Yeah, it's called the counter class when you create an object, and that's going to be this constructor. This counts static. That's why it increments 1 by 1 by 1 by 4, and this one is not incremented. Okay, that's why you get all this 4, 4, 4, 5, 5, 5, 4, 4, 4, and then here you only get 1, 1, 1, 1.
But it goes through it once because the original value of another count is 0, and it's incrementing to 1,
And that's it.
Stays there.
Stays there.
It shouldn't do it at all, right?
All of a sudden, this guy is called 4 times. This guy just get 4 right off the bat when you call this guy.
Can you make another count static?
Another Another
No,
run.
no, right. Public and no.
Mhm.
Public static and another count on the top, right there. Second line 5. No. Right? No. Don't change that. Just change line 5 and add static to it. Now run it again.
Yeah, that's what I'm telling you.
Where is it?
It's right here, 444. It was 111. If I remove this static here from here, it will be 1111. You want to see it?
Make
111.
another one. Another count start with 1 equal to 1. So I can see the difference in the numbers, or +2 or something like that.
You want a
Plus
static?
equal 2.
Static?
Yeah. Uh-huh. Mm-hmm. Oh, we call it 4 times. That's why.
One more count, right?
Mm-hmm.
One more count. Six. Remember that the final guy was 5. 5. So these guys will be called ones. And then remember, all of them are from the same class. Okay, but this one is not static. This one is static. So all of the objects will be updated. Okay, and the last one, as you can see here, is +5. It ends with 5 here, but when you call it again, this guy will increment by 1. It will become 6. Okay, it's kind of confusing, but it's just the way that you create these objects, right? And you start, when you create this guy, right, it will be called 4 times because you have 4 constructors here, right? And every time you call this guy, this one will be incremented. But when you play with that all the time, all the way until here, right, it's already 5, because you can see here, it's 5 already. It means that this guy was 2, right? But remember that 4 count originally was 4. Count for the first time was 4, right? So what happens when you call the constructor, that 4 will be added to, and then it becomes 6, because it's the same class, the same constructor, and all of the objects are updated. The static ones, they're updated. This one is not. This one becomes 1, and that's it. But all of the static objects will be added. Let me just have another one here. Let me see, public, static, int, and another count equals 5, right? And let me print it here. And another count. And then if I print it, I get 5. because I didn't increment it here. So let's see what happens. 9. Why? Why 9? Because count is originally 4, right? When you call these guys. And then when this guy comes here, what it does is just adds this 5 to 4, and then you get 9. If I put another 1 and I put, for example, 10, what do you think is going to be the result? If I put 10, what do you think is going to be the result? What was the original count? What was the original count? What is the value of count at the beginning? 4, right? So what it's going to do is add 4 to 10. It's going to be 14. So if we run it, 10? Oh, because I didn't add it. More, right? Okay, now it's going to be 14. You see? What it does is it's just adding the original count to all of these guys. Because remember, the statics are called first, and it's going to add that particular, the 4 times that it was called, the first one is 4, and then it will add that to all the static variables. This one will become 6, this one will become 9, and this one will become 14.
Yeah, but it calls another count 1. So that could be useful for something.
Yeah. Account 1 is 1 because it's not static.
But it does call it 1.
Yeah, it does. It does because when you create the object, it will call the constructor. But it increments this one by 1.
Mm-hmm.
And it stays there. Okay. Right. It just that all the objects update because they belong to the same class and they're static. Okay. They update. Let me do something here. Let me say 1 dot another count equals 2. Okay. Now let me print another count. Let's see what happens. It comes 2. It was 1 before, remember? Now it becomes 2. You see? Before another count, it's right here. Another count is here. It's 1, 1, 1. But now I updated that and it becomes 2. But if I do this, to another count, let's see what happens. It becomes 1. Okay.
That's because you haven't called.
Correct.
You called 2.
Because
yeah, so you haven't converted. You have not assigned another count to another number.
Correct, because another count is 1, no matter what. Okay, so now I can say 2, another count equals 3, right? Now if I print it, I get 3, right? And then I can say 3, another count equals 4, right? And then if I can print this, I say 3, another count, and then we get that. We get 4, right? And then I can say 4, another count, equals 5. And then I can do this and get 4. And then I get 5. Right? Can I do the same with count? Count? I can't, because count is static. So count static, you know? I can do that with 5 doesn't exist, but I can say 1 with another count, because another count is not static. Okay? Right? And remember that you cannot call a non-static variable from a static context. Right? So we have to do 1 that count. See? Doesn't work. See, cell 1 that count does not work. Let me remove this breakpoint here. So if I make count non-static, again, I get a problem here because non-static field count cannot be referenced from a static context. Okay, so the thing here is we're trying to play with static and non-static. Okay, that's why we're getting all of these guys to update, because they're static. We're calling from a static context. And this guy doesn't update at all because it's not static.
It does one time.
Yeah, only one time. Start with 0 and it does 1 and it stays there. Okay? And it will only update when I do this. Okay? Now let me try something here. Let me see if this works. So I can do count equals 20. Okay? Let me do that. You see? 20, 20, 20, 20, 10, 19, 19, 19, 19, 20, 20, 20. You see how it updates? How it updates? See? All of the fields will update. All of the 1, 2, 3, 4. Okay? So it will update no matter what I have. Okay? Because they're all static. Right?
I need a break.
Yeah, me too. So let's take a break, guys. Let's take a break for 10 minutes and let's meet back here at 6:55. Okay, guys. Okay, so let's create another class, and let's create a class named dog. Okay, dog. And then in this class, let's create a variable named count, and it's going to be static. Okay, int count, and let's set it to 0. Okay, now I'm going to create a method, static void increment count counter. Okay, and then we're going to say count plus plus. Okay, so that's going to be our method in this class. Right? Fine. Now we're going to say okay, so we're going to create another class, and this one is going to be dog tester. Okay, we're going to test that class. Okay, we're going to create our main method, and we're going to say dog husky equals new dog. Okay, we just create an object of the class dog. Okay, we just create an object of the class dog. So now we're going to say husky dot count. Okay, we get a warning here. So access static dog count, right? We get a warning here. If we run this guy, we get 0. Okay, so we get 0. Guys, do you know why we get a warning here? Do you guys know what we get a warning here? I wonder if you guys are here.
No idea.
Okay, the word count, the variable count is static, right?
Uh-huh.
Do you need to create an object to access that variable?
No, you don't.
No, you don't.
That's why you get a warning. So I can say dog dot count. And now I don't get a warning. because count is static. So now I can get 0 2 times, but the first time I get a warning, it says static member count accessed via instance reference. I created an instance of that class.
Hostess, okay.
So I created an unnecessary object because I can just access that variable, static variable count, with the class name. Okay. Now this method here is also static. Okay. So I can create another dog and say another dog and then new dog. So I create another object of that class, of the class dog. So now I can say dog increment counter. Okay. So you see the difference? If I do this, I'm going to get a warning, right? It doesn't even show, right? It doesn't even show. I can still put it and I don't get it any error, right? Right? I just get a warning. Same thing. So if I print this, I get right? Now, if I now print dog that count, then count is gonna be 2. Why? Why 2? Because I call that method 2 times. First time, second time. And it's supposed to increment count every time that I call it. So I'm calling once here and once here. If I call it again, right, and I'll just print count again, then I should get 3, right? And just calling that method and it's immediately incremented that count by 1. Because that's what I stated here in this method, count plus plus. Okay, remember when the variable is static or the method static and you call it from another class, you don't need to instantiate the class. You don't need to create an object of the class. Simply access that method or variable by just putting the name of the class dot the variable name or the method name. Okay. Now I want to set husky to null. Okay. Husky equals null, and then another dog equals null. 2 objects that I just set to null. Now I can do sysout dog count. All right. Now I get 3. That's fine. Now if I say sysout husky that count, let's see what I get. 3 as well. Okay, because every time that I call that method, last time I called it, it was 3. Okay, so now when I just print it, I get 3, right? But when I use the object to dog count, I get 3 as well. But I get a warning here, the warning that I got before. Now if I say sysout another dog that count, then I get 3 as well. Okay, remember that I created an object from the same class, and that count value is going to be the same no matter what object calls it. It's going to be that value. Okay, no matter what object calls it, it's going to be always the same value. I can create another object here and say dog one more dog, new dog. And then if I just sys out one more dog, that count, then I get 3 as well. No matter how many objects I create, that count is going to have the same value. Okay. The creation of objects, new objects, doesn't change that value. The value continues to be the same. Okay. Now let me do something here. Let me say dog, that count equals 10. Okay. Now I can say dog, new dog, equals new dog. Right. And I can say dog, dog2 equals new dog. Right. Now I can say new dog, that count equals 5. Now if I say sys out dog that count and I print it, I say 5 because 5 was the last value that I set. No matter where I'm calling that count from, always these objects are objects of the same class. Okay, so that count will have the last value. If I print this count right here, I'm gonna get 10. Okay, so the object, the reference doesn't matter when it comes from. What matters is the value, the variable count. And all the objects will be updated no matter what, because they're coming from the same class. And count is only one variable in the class. And this is getting values and values as we call this method increment counter. Okay, I can keep on creating objects and calling the variable count. It will always have 5 here, no matter what. So I can say sys out new dog, that count, and then sys out dog2 count. Okay, so now we check, we get all of them 5. So this is very interesting because I never said this. I never said this. Equal innocent. Still, when I print dog2, I still get 5. So no matter what I do, if now I use dog2 and I say count and equals 25, then whatever I print, I can print husky, that count. I can print new dog, that count. I can print dog2, that count. I can print any other object, one more dog, and the other one is another dog. I can have one more dog, dot count. And I can print another dog, dot count. Let's see what I have here. And I get 25, 25, 25, 25. All of the objects are outdated because they belong to the same class, dog, and the variable is only one. That is set new values. Okay? You see how interesting this is, guys? Okay? So this will return 25 and 25, 25, 25, 25. This will return 5, 5, and 5. Got it? This will return 10. So this returns 3. This returns 3. And this returns 3. Got it? This returns 0. And this one returns 0. This one will return 2. And this one will returns 3. Right? Got it. Okay. You guys understanding?
Yes.
I know it's 9 students in class, better than last time.
Yes, Professor.
Go ahead. Okay.
I'm sorry. What did you say? I didn't hear what you.
And I have 9 students better than last time.
Oh, don't worry about it.
Yeah.
Important thing is the ones that are here, that show up.
All right, static. Let's create another class called static. Okay. Let's continue with static. Static is very important. Okay. So public, let me have a private string name equals static. Right. Right. Now I'm going to have public static void 1. Okay. All of this works. Okay. Public static void 2. Perfect. Right? Now I can say public static void 3, and I can say 1 method call, 2 method call. Now guys, this is possible. Why? Why is this possible? Well, this is possible because this method is static and these two are static. If I just remove the static from here, I get an error because it says that non-static, this one here, cannot be referenced from a static context. Okay? So we've seen that several times. I have to make this one static, or both will be not static. All of them not static. So if I do that, then I don't have any issues because non-static can call statics, right? But we're working with static methods, okay? So statics can call statics and non-static can call non-statics, okay? Continue. Now we create another one, public static void, and that will be 4, right? But 4 would not be static. Okay, so this one would not be static. Now I can say 1, 2, 3. So this is something very interesting because you can call a static method from a non-static. What you cannot do is call a non-static, static from a non-static. That's what you can not do. And we can say here. So from a non-static, you can call a static. From a static, you cannot call a non-static. I don't know if you understand the tongue twister, guys. Do you understand the tongue twister? So you can call a static method or methods from a non-static context. But you cannot call a non-static from a static context. Okay, you want to see it? Let us call number 4 from here. There you go. You say a non-static method 4 cannot be referenced from a static context. Okay, so you can call static to static, non-static to static, and non-static to non-static. Okay, so let me put it here. Non-static can call non-static. Okay, right? Well, maybe if I can do this, non-static, non-static, static, static, and static, non-static. Non-static to non-static, static to static, and non-static to static. This one is non-static, so we can call number 3 that is static, and number 1 that is static, and number 2 that is static. Okay, that's how it works. Okay. And this, what it means is call. Okay, right? So now also we can do this here. We can say, is this out? Name. Right? So we can call a static, a non-static variable here. This is non-static from a non-static thing. So if I run this, well, I cannot run it because I don't have a main method. I cannot run it. If I don't have a main method, I cannot run this program. The one that runs the program is the main method. Okay, but just if you take a look at this, it works because it doesn't give you any error. Okay, now let me create another guy, but this time it's going to be the main. Okay, so I'm going to create the main. Right now, the main, we're going to say static dot one. Why do I do this, guys? Why do I do this? Why? We're calling them one method. Why are we doing that? Why are we able to do this like this? Why? No answer?
Because one is static?
Correct. That is correct. Because one is static. If one is static, we don't have to instantiate the class. Okay? We don't need to create an object. Okay? I can do this if I want to. I'm going to get a warning, right? Static, new static, right? And I can say s.1. I'm going to get a warning, right? But still, it works. But I don't need this because I am referencing static from an instantiated reference. So I don't need to do this guy because static class has a one method that is static. Okay. Now, I can also do this, right? Why can I do this? Why?
Because they're static.
And I'm in the same class. This is
I'm in the same class.
right. And from a static, we can reference statics. 1, 2, and 3. But can we do this?
No.
No, we can't. Because from a static, you cannot call a non-static. Okay? So you can do from static to static, but not from static to non-static. Okay? So if I run this guy, I'm going to get beautiful. No, I'm not going to get anything. I just run it this way. I'm going to get this. Actually, I don't get anything.
You don't get anything. You haven't.
Okay. Yeah, because I haven't called 4. That's why I'm not getting anything. Inside 1, 2, 3, there's nothing. But I will have to call 4 to be able to print something. Okay? But if I make 4 static, then I'm going to have a problem. Why do I have a problem? Because name is non-static. Name is non-static. So we have to make name static, and then I can reference here and get call 4 here as well. Right? And now I'm going to get the name. Okay, static. Okay, so let me put it back what it was. It's just a demonstration. Okay, and that's it. Let me make static. Okay, so let me make 4 on static, non-static. You see? So 4, I would say your 4 is non-static. Okay, cannot be called from within a static context. Beautiful. But something can be done. I can static my instance equals new static and do this. My instance dot 4. Hey, I can do that and I don't get any warning. Why? Because 4 is non-static. That's why I can create an object. I don't need to create an object here because these methods are non-static. I'm sorry, are static. This one here is non-static. As you can see here, is non-static. That's why I can instantiate the class and call the method. Now, if I run this, I'm going to get static. There you go. You see, guys, the difference? For non-static methods, I can create an object. For static methods, I don't need to create an object. I can simply use the name of the class and find the elements of that class by using the dot notation. Okay? I can also do this. New static dot 4. This is method chain. Okay? Method chaining. So I can say, create the object of the class, call the constructor of the class, and then dot 4. Okay? I can do that, and I get static again. Okay? That is possible too. Okay? I cannot do that with the other guys because the other guys are static. I can only do that with non-static methods. Okay? Can I do this?
Nope.
Not a statement. It's not a statement, right? That's for methods. Can I do this? Yes, because that's a statement. It's inside a print. So if I do this, I get static again. So this is possible too. This doesn't make sense because you cannot do anything with this. Okay? But what if you do this? You see? And now you print name. And you get here, static again. Beautiful, huh? Java is so unpredictable. It's incredibly unpredictable. Okay? I don't know. The person that invented Java was not okay. I was genius at the same time. Okay. So you guys see the difference between static and non-static? For static variables or methods, you don't need to instantiate the class. Simply use the class name and refer to a variable or call the method. Right? Right? Good. Let's create another class. And this is going to be about final variables. Final variables. Okay? We're going to call it final variables. Okay? When it says final, you cannot change the value. You cannot reset the value to something else because it's final. Okay? So I'm going to say private static final, and then usually final variables are with capital letter. That's its naming standard. Okay? That represents a final variable, a constant. A constant is written with capital letter, just like that. Okay? So now I can say private static. Remember this guy? A list. Remember when we saw collections? A list. And then I can say values. That's a final. It's a final list as well. New array list. And then I just put the semicolon at the end. Okay. So I just created two final variables. One is an integer, static integer, and the other one is a static list. Okay. A list of strings. Right. So now I can create my main method, and I can say int array, right? My array, an array of integers. Remember, this is a list of strings, and this is an array of integers. Okay. New int, and remember that the size has to be a constant. So in this case, it's going to be size. So it's going to be an array of integers with 10 elements. That's going to be the size of, or the length of that. I can say now, sys out, my array dot length. And then we're supposed to get 10. Right? There you go, it's 10. That's the length of the array. Okay? Now, you cannot do this. You can't do that. You see? Cannot assign a value to a final variable size. You can't reassign values to a final variable. Okay, so this is run. Run. You cannot do this either, guys. Pay attention. You cannot do that either. You cannot alter the value of the size variable. You can't. So this is wrong. Because when you do that, it's going to become 11 if it is a normal variable. But as it is a final, it will not work because this is the final. 10 is the value. That's it. Period. 10 is the value. That's what Java is telling you. My friend, this is up to you. If you're telling me that this guy is final, that's the value. That's it. Change it before, but not now. Don't try to change it now. So this is wrong. Well, variable size is final. Okay. Keep an eye on that. Watch out for final variables. Okay. You can say int double size equals 2 multiplied by size. Okay. This is possible. You're not altering this value. You're just multiplying that guy. So now I can say double size, and then double size, right? So that's possible. Why not? Okay. So now we have 20. Okay. 20. That's fine. 2 multiplied by 10 is 20. As long we don't alter the final value, we're okay. Or we don't not alter. We don't try to alter. We will never be able to alter it. It's just as long as we don't try to alter it, we're going to be good. You can also use the size for a for loop. So you can say for int I equals 0. And then we can say if I is less than size, right? Then let us do this. Sys out my array I. Right? Guys, what do you think is going to be the value here? What do you think is going to be the print of this? And I will give you $10 cash if you tell me.
Amount is less. Price amount is less.
Well, I'll just increase the value. I will give you $20 if you give me what the print of this is.
Okay.
Guys, make an effort. It's $20 for free.
$20 for free. Okay, double size, 2 to size, 20. 20, so
Okay.
20, 21?
No. Okay, when you create an array with the size 10, what are the values of the array? The array has values inside. What are the values of the array?
It's 1.
I'm sorry?
0, 0, 0, 0.
Makes sense. It makes sense, right? 10 zeros.
Mm-hmm.
But it's too late for the $20. All right.
Hey, I told you before you said it, so I want my 20. Hey, I want it cash. I have to pay taxes on it.
I think you were muted because I didn't hear it. You can send me your cash app and I will send it to you later. Okay, so yes, it's empty. It's not empty. It's just 0, 0, 0. Okay. This list is empty. Okay. It's empty. But this guy is not empty. It's just 10 zeros. Okay. Now, can I do this? Values that add and then changed. Okay. Let me just say this out, values. Let's see what happens. Changed. So that's possible, right? Now,
I'm talking on mute. Can you move up? I want to see how you structure values. Okay, there you go. So it's a list, values, new array. It's just no content. Empty.
yeah, it's empty. That's right. So now, values equals new array. So this is wrong, guys. This is not the way that you add something to a list. The way you add something to a list is using the add method. So this is wrong, okay? It's just an example for you guys to see that that might appear in the exam, and this is completely wrong. Guys, are you using Quizlabs to practice? No? Yes?
Not yet.
Okay. So I can say
Mhm.
final. I'm sorry. Is that again?
No. Mm-mm.
You can say final int
Wait a minute.
Sorry?
How can you add something that is final? I'm confused by this. Can you go back to this value? So you have an array.
Mm-hmm.
You have an array,
Mm-hmm.
right? It's value, but it's final. So how can you add something to something that is final? That is unique.
Yeah, that's right. But this guy's an integer. It has a value already. This one is empty.
Mm-hmm.
This one is empty.
It might be empty, but that's the way you said that it's final. So
Okay.
if it's final, how can you add something to it if it's final?
That's a good question. Just give me 1 second. Let me remove this guy from here. Okay. Now, this element has 1, right? Right?
Mm-hmm.
Let us try to remove something from here. Index out of bounds, index 1. No, that's not, because it has to be index 0. I don't have an index number 1. Okay. Now I'm going to print values.
Mm-hmm.
Right. Empty. Okay.
This does not make sense to me.
Okay. So let me remove this guy from here. Okay. I just removed it. That is possible. You see, that is possible. That's what final prevents you from doing. You
To assign
cannot,
it to a new array, to assign it to something new.
correct. You cannot do it when it's final. Okay. So what the final keyword does is prevent you from assigning a new value to the synapses variable. So you cannot write this if it is final. If I put final here, then this is not possible. You see? You cannot assign a value to final variable value. Make values not final, and then it will work. So this is not possible. So you can add or remove, because remember, this is an empty array, a list, and list is resizable. So final doesn't prevent you from adding or removing. Final just prevents you from assigning a new value this way. That's what it does. So this final int here, I cannot do this. My number equals 11. You know that already, guys. This one will not compile because, you know, that's not compile. Because, you know, my number is final. It's a constant. You cannot change it. So let me see if I can do this here. Add, and then we add it. Okay. So I can print it, and I'll add it. Okay. Let me just remove this guy. And I have changed and added. Okay. So you can basically add elements using the add method, but you cannot add values, assigning values using this. Right? That's what it does. Okay. So let us create another class. And this one is going to be called static initialization. Okay. And I'm going to say private static final int size. Okay. So it's going to show an error now, but when we assign the value in a static block, it will change. Okay. So private static int 1. The error that you get here is because final variables, they have to have a value. Okay. But in this case, we're not assigning a value. That's why we get that error. I'm going to say private static final into, and it's going to give me the same error because it's final, but I'm not assigning anything. In the case of line 5, I'm not getting an error because that variable 1 is not final, but the other 2 are. So private static final, and this is going to give me no error because I'm assigning a value. Okay, that one is fine. And then I can create another variable, but this is going to be a list. I'm going to make a final list of strings. And then I'm going to call it names and then new array. Now, I'm going to create a static block like I did before. And now I'm going to assign the values. Okay, so I'm going to say this out. First, static init. Okay, we're going to say int rows equals 5, int columns equals 4, and then we're going to initialize size, and we're going to say rows multiplied by columns. Okay, and then the error disappeared. This line here means that it hasn't been used. It hasn't been accessed yet. Okay, so if I comment this out, I still continue with this arrow here, this red line. But if I uncomment it out, I have this because I'm just, and guys, to be able to initialize this variable, the initialization has to be inside a static block because the variable is static. Okay. So I'm going to create another static block. And I'm going to say sysout third static init, right? And I'm going to say names add Jimmy. And then names add Timmy. Okay. I'm going to create another static block, right? And now I'm going to initialize the other ones. Okay. Okay. I'm going to create another one, right? And this time it's going to be 1 equals 1. Okay. Then it disappeared. 1 equals 1. Well, actually, 1 doesn't, it's static, yes, but it's not final. We're going to say 2 equals 2, right? And it changed the color because this one is final. You can see the finals, they have an orange color, and the ones that are not final, it has a white color. The other one is 1 equals 3, right? 3 is 3, right? And then we can do this because 1 is not final. If 1 was final, I couldn't do. That's why I cannot do this, because 2 is final. Okay, I can do that with 1 because 1 is not final. So this one equals 3 cannot happen. First, because 3 is already initialized, right? And cannot assign a value to final variable 3. Okay, so this is not correct. And this one is not correct either because 2 is final. Okay, 2 is final, right? And it's already initialized here. So it says that 2 might already have been initialized. So this is wrong as well. Okay. Now we can say 1 equals 2, and then 1 equals 3. So we can do all of these guys at the same time. We can simply reassign values to the ones that are not final. To the ones that are final, you cannot do that. Okay? So I can do this PSVM and say sysout names. Okay. Let's see what happens. So we get first static, was first static here? Where first, I forgot to put this S here. Okay. So we got first static init right here, the first static block. Then we get the second static block. We add the names, right? And then we just call the names. And then we get Jimmy and Timmy. Okay? As you can see, guys, very important. And the point of this lesson is that even before the main method is called, the static blocks are loaded. So maybe you thought before, oh, the first thing that happens is the method call, main. Well, main is the one that runs the program, but before the main method is invoked, the static blocks are loaded. Okay? That's why you have static so important. The static are loaded before the main method. Okay? As you can see here, the main method is printed here, but way after the static blocks are printed. Okay? So now, if I have a constructor here, constructor, right? And I say, what is the name of the class? Static is, I say, public, static, and I say sysout constructor, right? So I can do this, static, I can do new static session, this. See what happens. You see, the constructor is even called after the static. Okay? So anyone can think the constructor is even called before the static. No, the constructor is called before the static. Okay? So the static is the first one, right? Then the main method is called, and the constructor is called. Constructor here, it prints this. It doesn't matter where you put that. If I put it here, let's say I put the constructor maybe here. Okay. To get the same thing, I can simply put the guy here and then call the constructor and then Jimmy. But you can see the constructor is before or after this guy. Okay? Static always first, then constructor. Okay? No matter where you put the constructor, I put the constructor before the static blocks. Still, I get the static blocks before the constructor. Okay? You see the order of calling? These guys are after the constructor. No matter what I put the constructor before or after, it will always call the static methods first, the static blocks first. Okay. So now, let's pass data between methods. That's another class that we're going to create. Guys, do you understand this? The order here? You realize how the static blocks are called first? You guys see it?
Yep.
Okay. So let us create another class, and the class is going to be passing data between methods. Okay. And now we say our friend, this guy, and we say int number equals 4. Sysout, super easy, number equals number. Okay, we just print that, and then simply we print number 4. Okay, now let us call a method new number, and let us pass that number. Okay, right? And then outside the main method, I'm going to create a method, new number method, right? So I'm going to say public static void. I have to make it static because I'm calling this method from a static context. Okay, and then I'm going to call it new number. Right now, I'm going to have int number because I'm passing a number. Don't forget that. I'm passing a number here, which is 4, passing it to the method. This has to match the signature of this method. It's new number and the integer. Okay. Now, what is the value of this number? Can someone tell me what is the value of this number? This argument? Can someone tell me what's the
4.
value? 4.
0.
4, because that's what we're passing.
4, yes.
Okay, that's what we're passing, right? So we can say sysout and say in new number equals number. Okay, so now if we run this, we say in new number equals 4. So the same value that we're passing here is the same value that we're getting here, and then we print it. Okay, so far so good. Okay, but what if I do this? Number equals 10, and then we just print the same thing. What do you think is going to happen? What do you think is going to happen? Let us see it. 10. Because we reassigned the value here, right? The value was 4, but we reassigned the value and just give it a value of 10, and that's what we printed here, right? Why do we say this? So let's do it. It won't affect anything because this variable becomes local here. Okay, this variable number here is not the same as this. 2 different variables. Remember, this variable is from this block, and this variable is from this block. Even though you're passing this 4 here, it becomes a new variable in this context. It's not the same variable. Okay, so this final doesn't make any difference when we're doing this. It makes a difference for this. It makes the difference for this context. If you say number equals 15, we cannot do that because number is a final. Okay, so in this context, it makes sense, but it doesn't make sense here because this variable is a different variable with the same value. Okay. Now, let's have, right? this same print here. Okay, so we're gonna have the same values. Okay. But what happened here? What happened here? Can someone explain to me what happened here? And it just confirms what I just told you. What happened here? We get here 4, 4, 10, 4. What happened?
It's final in that block, so
Sorry?
it's still 4. It's in the same block.
Correct. Because this number here is still 4. We're not changing anything. The change happens here. 2 different blocks.
The variable has the same name, but it's not the same thing.
Correct. It's not the same scope. The scope of this variable is this main method. And the scope of this variable is this new number method. 2 different variables. Okay? And then when you're done with this method, you call it here. When you're done with this method, it goes back to the main and it prints number again, which is 4. These 2 numbers don't have anything to do with each other. 2 different variables. It's just a matter of scope. Okay? Just a matter of scope. Now, let me create a string, and name it name, and say Jimmy. Okay? Now I'm going to say this out, name equals name. Okay? It's fine. We print that, and then after 4, we get Jimmy. That's fine. Okay? That's okay. Now I'm going to say new name, which tells me that I have to create a static method, name new name, right? And we're going to create it here. It has to be outside the methods, okay? It cannot be inside any method. Static void new name. And then we're going to pass a variable name. Okay? We're doing almost the same. Now, sys out in new name, name equals name, right? If we print this in new name, name equals Jimmy, okay? Now, if I say name equals Timmy, and I print the same variable, right? Then we get 2 different names. So it is the same concept behind this guy here. Same concept. We're just playing with the context, with the scope of the variable name. Okay? This name here is not the same name as here. Okay? Now I'm gonna print it again here, and I should get Jimmy again. Okay? Because it's a different context. Right? I get Jimmy again. Just like we got here 4, 4, Jimmy, Jimmy. Okay? Now let us do something. Let us create a string builder. Okay? String builder. So we're going to say string builder. Remember this guy? SB equals new string builder, right? We just created an object of the class string builder. So now we're gonna call a method and say build SB. Okay, we're gonna call that method. So we have to create a method here, and we say public static void build. And then we're passing a string builder because that's the type of that SB that we're passing. S. Let's name it S, like a string builder. We're passing a string builder here, right? This SB is of type string builder. So that's why we have to put here, string builder, okay? And now we're gonna say, this is wrong. Okay? You don't do that because you don't need to do it anymore. Okay? That is already here, right? Because it comes from here, right? So you don't need to do this. Okay? We're gonna do S dot append, and we're gonna add Tom, right? Now we're gonna say here, S out, string builder, equals SB. Let's print it. Tom. You see here how we can pass this string builder, right? We can pass this string builder. Remember, the string builders is mutable. Okay, it's mutable. So we pass this string builder, we send it here, we add a name to the string builder, and we get it here, and it adds it. So this string builder is the same as this string builder. Okay, is the same guy with different name. So I can add another one, and I can say S append Cortez, right? And I can print this, and I have Tom Cortez. So space here, Tom Cortez. So in the case of string builder, it is always the same context. So we are appending values here, and this string builder is being affected. Okay, no matter what it is the same object. Okay, I can continue to append things here, right? Left, right? Continue to append things here. Append this, then append this morning. Okay, morning. And then I get that here. Tom Cortez left this morning. Okay. So that's how string builder is created. Okay. Now, I cannot do this. Sys out S equals S. You see? Because that variable doesn't exist in this context. It exists here, but this guy is connected to this guy. Okay? So this is wrong, right? Yeah. I cannot do this either. I cannot say string builder S equals SB. This will not work. because it's redundant. Local variable is redundant. Okay, I'm just creating a new one and just assigning this one to this one. That doesn't make sense. Okay, and of course, pen Anthony. Okay, now if I print this, Anthony can be added to that. Okay, why am I doing this? Because this guy can be linked to this, right? And then whenever you add something to this, it will be affected with this. We saw this when we saw a stream builder. Okay, whatever I add to both, either S or SB, is going to be printed here, no matter what you add, because they're linked. Anthony Cortez left this morning. I can add more if I want to. A pen, Julian, right? And then Julian is going to be added to that stream builder. Okay, guys? So this is mutable. This guy is mutable. And as they are connected, either here or here, every time you add something to that stream builder will affect both S and SB. Okay? We saw it before, but it was a long time ago when we saw stream builders. So we're passing values to a method, okay? Passing values to a method. Okay. If you take a look at when we started stream builders, you can know that, and I think it was Legenia, the one that asked me about this link here. I remember that. She asked me about this link here. That one, when you add to one, it will be affected if you add to another one. So if I say SB add append Dunieski, right? It just prints Dunieski there too. So no matter what I add, you know, they're linked one way or another. All right. And it just changes here because this guy refers to SB. That's why. Okay? When I add to this guy, when I ask to S, and then I print SB here, I see that all the changes reflect when I add it to S or SB. They all reflect in the same stream builder. Okay. Very interesting. Now, let's create another class. And this time is going to be returning data from methods. Okay, returning data from method. So let me create my main method. Create a variable number equals to, and then string word equals XYZ. Okay. I can simply say number equals number, okay? Like calling a method, right? A method name number. Okay? I'm just calling a method name number, static method. So I can say public, static, and I'm returning an integer, okay? Int number. I'm passing an integer, name number, right? Everything is fine so far, right? And I'm missing a return statement here. That's why it's telling me results of this one is nor. So guys, nothing will happen here because of what I explained to you before. So I can say number plus plus, and we can say return number. Okay. Now, this will not do anything. If I run this guy, I don't see anything. Why? Because we're not storing anything here. We're not storing this in a variable. Okay? So if I say number equals this, right? If I say number equals number, and then I say sysout number, then every time that I call that number, it's going to increment 1 and return 3. Why? Remember, the number was 1 before, was 2 before, but now when you call this method, it, get the numbers and increments by 1, and then the number is going to be 1. Okay? Now, I can say this number here, I can say word equals word. Word, parenthesis word. So basically what I'm doing here in calling a method, name word, I'm passing a word. Okay? The word is right here, XYZ. So I'm going to create a method here, public static, and I'm returning a string this time. And I'm call the method word and pass string word. Right? And now I can say word plus equals a, we're just concatenating this, right? Concatenating this, and then I'm returning word, right? So every time that I call this, it's going to concatenate a. So if it is XYZ, it's going to be XYZA. Okay? So now, if I grab here word, right? Let's print this, and we get 3 and XYZ. Why? We're getting no A here. Why? Why we're not getting an A here, guys?
Can you please scroll down?
I'm sorry?
Can you scroll down on the, yeah, thank you.
Well, we're not getting an A because this is completely ignored. We have to say word equals. Okay? Now, if we do this, then we get an A. Okay? Remember, this is not doing anything. Remember what I said, when you return something, something has to catch it. Returning something is like throwing a ball at someone. If the person doesn't catch it, the ball will not be caught. Okay? So you have to catch it here, and then you can leave a space here, and then you can have the 2 elements here, 3 and XYZA. Okay. We're calling the method, passing the word XYZ. It's gonna get the XYZ here. I'm gonna say word XYZ plus A is AYZA. I'm returning that to this word here that is being assigned this value, AYZA, and then I print it here. And that's why I get this. If I don't do that, what I can do is another alternative is doing this. It's what I told you before, guys. You can do that. You have the same results. Okay? So if I just print it, got the same thing. Okay? So this returns X, Y, Z, A. Right? Instead of just assigning this to a variable, storing in a variable, I just call the method and pass the word. That's it. Okay, guys, let's see one last class, and then we're done for today. One last class, let's call it overloading. What is this? Overloading methods. Okay. So we have a method called public void walk, and then int miles. We're passing an integer named miles. Okay, nothing to do here. We just give you this way. We're gonna create another one, public void walk, and then short feet, which is kind of contradictory because we have the same method. But guys, notice something. Overloading doesn't change the name of the method, it changed the arguments. That's overloading in Java. We're calling the same method with different arguments. Okay? The method call has to match the signature of this method. You have to pass an integer here, you have to pass a short, and then the other one, we're gonna say public Boolean walk, and we're not passing anything. Okay? We're returning false. Okay? We're not changing the name of the method, we're just changing the return type. We're not passing any arguments. We're not changing the name, we're changing either the return type or the arguments. Okay? The names continues to be the same. I can have void walk int miles short feet. You see, we just changing the arguments. In this case, we change the arguments and change the modifier, the access modifier. Instead of being public, now is default. We don't have anything. Okay? So that's going to be it for now. We continue. We can say public void walk, and now we're going to say float miles. Okay? So this will not compile. If we say public int walk and then float kilometers. Probably you've returned this guy. You see? Missing return statement. That's why it doesn't work. Okay? So if you don't have a return statement, don't even try. Okay? It would not work. So like this one. Public static void walk, and then we have float miles. Now this one would not work because it has the same name, it has the same argument, it has the same return type. Okay, so this one doesn't work. Overloading is just keeping the same name, but you have to change either the arguments or the return type. That's overloading, but it's the same name for all of them. So you see walk, 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 all of them. Okay, so we can have another one. We can say public void walk, and then now we have to change the argument, and we're passing an array of lengths. Okay, and this works, right? This works. Now, if we do this, public void walk, right? And we say int vars, then we say this, we get an error. Why? Because we already have an array here. Okay, integer, this is an array of vars. The name doesn't matter. The name could be anything. It's just the type that is the same. So this is not overloading. Okay, overloading, same name, different arguments, right? Different arguments, different return type, right? Okay. Right? We can say public static void run, and then int length. That is another guy that you can do if you want to. You can have public static void run, but this time it's going to be integer. That's a wrapper. It's a different type, right? Even though it's an integer, but it's a wrapper class. Okay, we can have public static void run, and then double kilometers, right? That's fine too. Okay, as long as we have different types or different return types, that's fine. Okay, so we can say public static void jump, and then we say string s, and then we say sys out string. So that's fine, right? Now we can say public static void jump object O, and this is out object. Guys, this is overloading. We're overloading methods using the same name, different arguments, different types. Okay, we can have public static void main, right? And then we can have the string. This is the main method, okay? Args. And we can say run 9L. Okay, we're just calling the run method and passing a long number, right? Here, an integer can be promoted to a long. Okay, so I can say run test, because that will match the signature Okay, sorry, that's not wrong. It's jump. Jump, it will match the signature of this jump that passes a string, right? And you can say jump 25. It will match the signature of this guy. This is jump, right? Jump that has an object here, right? And we can say sum 1 and 2. We see sum, and that sum can be here, public static int sum, and then we say int, okay, var numbers, system out, sum var args, and then we can say integer sum equals 0, and then we say for int I equals 0, or for int I in numbers. Okay, that's the array that we're passing here. That's 1 and 2. Then we can say sum equals I. And then that's going to be 3. And then we can say return sum, right? So now we just run this, and with this guy here, but to be able to print this guy, we have to say this out, and then we get the result of that. We get, is this the main method? It's returning sum. Oh wait, I'm not running this guy. So we get this number 3. Okay, we get string because we are calling this method here. Test, we go calling test. We're calling the object, which is this int. Remember, this is an integer. Okay, this object is an integer. This O here, right? Right? Maybe we can say O. See what happens. And we're getting number 25 here, right? That's the signature, 25, right? And then string, we can put here equals, and then S, and we're gonna get this test here, right? Test, you see? So guys, it's basically, we are just using the same name. We're just changing the arguments, right? And then when you call them, call each method, it has to match the signature of the method. So Java will look for something that matches this, something that matches this, and this is gonna be this string here is jump, string, test, jump, integer, which is an object, this one here, right? I can say, for example, someone has a float, walk, and then 2.2. So walk 2.2. Okay. No, because walk is not static. So now it says walk 2.2 is a double. Okay. Okay. So I'll have to walk, 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 float, float, walk. Okay. So that's what it is, guys. And, you know, it will match that particular signature. Okay. That is overloading in Java. Whenever you hear overloading, you keep the same name, change the argument, or simply change the return type. That's it. That's all about overloading in Java. Okay? Do you guys understood? You understand, guys?
Yes.
Yep.
Okay, long class, eh?